We're here at gotomath.com. Click on the calculus button. Let's go down to concavity. Yeah, we're doing this one right here, which is pretty much the same as the last one, except all we got to find is concavity. Okay, so, alright, let's write that down. Let's see, minus 3 plus 3. Is that all I got to remember? Seems like that's all I need to remember. So we have, you know what? How about I use some green? Is that cool? Use some green. Let's look at it. And we'll deal with it. H of x is equal to, and I'm going to go ahead and write this in the exponential form. That was x minus 3 raised to the 1/3 power plus 1. Okay, I meant to say plus 3. I was looking at my paper. Anyway, let's take the derivative. We got h prime of x is equal to, bring the 1/3 out front. You have x minus 3 raised to the negative 2/3, because we're going to subtract 1 in the derivative of that. Oh, let's look at this. I always forget. Derivative of the inside is 1, so we bring it out, and we got nothing. Okay, and then we have h prime double prime of x is equal to, bring the negative 2/3 out, so we'd have negative 2 ninths x minus 3, and that's going to be negative 5 halves, no, negative 5/3. Negative 5/3, yeah. And then derivative of that, oh, there is not that. Derivative of the inside, looking at the wrong problem, is 1. Okay, we'll rewrite this a couple more times. So we have negative 2 over 9, and then we have x minus 3 raised to the 5/3. Easy enough. So remember, we're just looking for concavity this time. We want to set this thing equal to 0, because that's what we do. Then we have x minus 3 raised to the 5/3. Right, so, well, there's nothing here that'll make this 0, but we do need to look in the denominator. Alright, look in the denominator, and what makes the denominator 0, and it looks like it's going to be 3. Okay, so that's important. Is 3 in the, well, it doesn't matter, but it is in the domain of h of x, by the way. And actually it does matter, because that means that we can pick a number to the left of 3, and we need to pick a number to the right of 3. Those are our test points. 4's in the domain up here. Okay, so now we want to take h double prime of 0, and all we care about is if this is a negative or a positive number. So let's look at that. Here's our derivative. So if I plug 0 in, I'm going to end up getting negative 3 raised to the 5/3, which is going to be a negative number. Okay, and yes, be a negative number. And then we have a negative up here, so negative over negative is positive. Right, so this is going to be concave up. And then if I take 4 and plug it in, we get 4 minus 3, which is 1, and of course this is going to be positive, but then we have the negative out here, so that's going to be negative, right? So that'll be concave down. I should have written h double prime of 4, and this was a negative number. Like I said, we don't really care what the actual value is, other than it has what the sign is. Okay, so concave, okay, forget that. Concave up is negative infinity to 3, and concave down is from 3 to infinity, right? So let's check all that out. So as you can see by just looking at the graph here, and of course this red dot's indicating that inflection point, right? Indicating the inflection point, which we were just asked in the other problem about that. Oh, let's go up here, click on answer. Let's make sure everything's good on that. And it looks like concave up from negative infinity to 3 and concave down from 3 to infinity. Yes. Alright. So you'll want to come on by and say hi, and you might see me there. Alright. Bye.